You are welcome to online lectures with Fameternity the Schoolboy. Today we are going to take a look at mathematics and we have a question on the board. The question says, if x is a set of all prime factors of 44 and y is a set of all prime factors of 60, the elements of x union y and x-intercept y respectively are A set of 2, 4, 35, 11 and a set containing only 4. B a set of 4, 3, 5, 11 and out of 3 and 4. C a set of 2, 5, 11 and that of 2. A set of D a set of 2, 3, 5, 11 and that of 2. So to answer this question, we need to understand what a prime number is. Then we need to understand what a factor is before we can understand what is a prime factor. What is a prime number? A prime number is a natural number that is greater than 1 but has only 1 and itself as its factor. That is, it can only be divided by 1 and itself without any remainder. Now, what is a factor? A factor of a number is a number that can divide that number without what? Any remainder. So as you can see, now let's look at this in 4 and 2. If 2 divides 4, you have 2, no remainder. So 2 is a factor of 4. By extension, 4 is a multiple of what? 2. Then 6 and 3. If 3 divides 6, we have 2. So 3 is a factor of 6. 2 is also a factor of 6. So 6 is a multiple of 3. 6 is also a multiple of 2. But 6 is not a factor of 4 is not a factor of 6. Because if 4 divides 6, you will not have, there will be remainder. You start getting 1 remainder. So 4 is not a factor of 6. Neither is 6 is a multiple of 4. So now let's go. Now prime numbers. So 1 is out of prime number because we say that prime number is a natural number above greater than 1 that has only 1 and itself as a factor. That means only 1 and itself can divide that number. Look at 2. There's no other number that can divide 2 except 1. If 1 divides 2, we say you have 2. And 2 itself, if 2 divide 2, we have 1. Another prime number is 3. No other number can divide 3 except 3 and 1. Another one is 5. No other number can divide 5 except 5 and 8, except 5 and 1. Another one, 6 is not a prime number. 7, another prime number is 7. No other number can divide 7 except 7 and itself. 9 out of 8. 8 is not a prime number. 9 is not a prime number because 3 can divide 9. 2 can divide 8, so they are not prime numbers. 10. 5 can divide 10, so 10 is not a prime number. 11 is a prime number. No other number can divide 11 without remainder except 11 and 1. 12 is not a prime number. 13 is another prime number. 14 is not, because 14 can be divided by 2 and 7. 15 is not, because 15 can be divided by 5. 16 is not. 17 is a prime number. 18 is not. 19 is a prime number. 20 is not a prime number because 20 can be divided by other numbers. So 21 is not, but 21 can be divided by 3. 22 is not, 22 can be divided by 11. 23 is a prime number. 24 is not. 25 is not, can be divided. 26 is not. 26 can be divided by 2. 27 is not, it can be divided by 9. 28 is not, it can be divided by 2. 29 is 29 a prime number. 29 is a prime number. Because 29, nothing else can divide 29 except 29 and 1. 30 is not. 31 is a prime number. 32 is not. 33 is not. 34 is not. 35 is not. 36 is not. 37 is a prime number. 38 is not. What does 39? 39 can be divided by 3. We have 3. So 39 is not a prime number. 40 is not. 41 is a prime number. 42 is not. 43 is a prime number. 44 is not a prime number. 45 is not. 46 can be divided by 2 is not. 47 is a prime number. 48 is not. 50 is not. 52 is not. 53 is a prime number. 54 is not. 55 is not. 56 is not. 57. What can divide 57? Can 3 go? 3 divide 5. We have 1. 1 remember what? 2. 3 divide 5. We have 1 remember 2. Can 3 divide 27? We have 9. We have 7. 2. So 57 is not a prime number. 58 is not a prime number. 59 is a prime number. 60 is not a prime. So these things are the prime number between from 1 to 60. These are prime numbers. So now let's stop. Let's go back to the question. The question now says x, a set of x. So x, let's list the set of x. X is all prime factors. What are factors? Factors are, as I defined before now, are factors. A factor of a number is a number that can divide that number without remainder. So factors of 44. Remember, they say prime factor. These are all the prime factor, all the prime numbers from here to here are prime numbers from between 1 and 44. Then from here to here are prime numbers between 1 and 60. So let's sort the x out first. So they say all prime factors of 44. So let's look at from all these numbers here are prime numbers. So let's look for numbers here. Prime factors are the numbers here from here to here that can divide 44 without remainder. Let's go. Can 2 divide 44 without remainder? 2 divide 44 is 22. So 2 is a prime factor of 44. What else? Can 3 divide 44 without remainder? No. 5, no. 5 cannot try it. 7, there will be remainder. 11, there will be no remainder. So 11 is a prime factor of 44. 13, there will be remainder. 17, there will be remainder. 19, there will be remainder. 23, there will be remainder. 29, there will be remainder. 31, there will be remainder. 37, there will be remainder. 41, there will be remainder. 43, there will be remainder. So the only prime factors between all prime factors of 44 are 2 and 11. 2 and 11 are the only prime factors of 44. Let's go to y. Y says prime factors of 60. Let's go. Can 2 divide 60? Yes. 30, it will give you 30 without remainder. So 2 is a prime factor of 66. What of 3? 3 divides 60. Yes, it can give you 20 without remainder. So 3 is a prime factor of 60. Can 5 divide 60? Yes, 12. It will give you 12. 12 without remainder. So 5 is a prime factor of 60. Can 7 divide 60? Cannot. It will give you remainder. 11 will give you remainder. 13 will give you remainder. 17 will give you remainder. 19 will give you remainder. 23, 29, 31, they will all give you remainder. 37, 41, 43. 47 will give you remainder. 49, 51, 53, 59 will all give you remainder. Wait, I noticed something now. Is 51 a prime number? Let's see. 51 divided by 3. What will happen? 51 divided by 3. 51 divided by, this is 1. 17. 17 times 3 is 1. 51 is not a prime number, please. 51 is not included. It's not a prime number. Please correct it. 51 is not a prime number because 3 can divide 51. Alright, let's go. So these are the prime factors of 60. But let me check other ones. So in case I made a mistake, let me check other ones. So let me check other ones. What number can divide this? What number can divide this? No. 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 I think these are the prime numbers from 1 to 60. Alright, let's go. So these are the prime factors of 44 and these are the prime factors of 60. Now let's go. Let us now, we ask the element of x. So x union y. X union y is the element, and so you combine this and this. So there's 2 here, there's 2 here. So we'll pick 1. This is 2. Then 3, 5, then 11. These are elements of x union x and y. So now let's look at s intercept y. By intercept, to me, I mean the one that this one has and this one. The one that this one has, that is common between this and this. Do you know what that is common between this and this is 2? So s intercept y is what? 2. So the answer is this and this respectively. So which option satisfies this? A is not A because A has 35. If you say, by me looking at this now, you know that this is not even a prime number. So this has cancelled A. I just decided to solve this for those that don't know how to, that have issues with prime number, prime factors, prime numbers, prime factors. That's why I listed it. If not, I would have just look at this as these options and and eliminate and get my answer. But I solved it for those that are having issues with prime numbers, prime factors, and what have you. By 4 being here alone has cancelled this A because 4 is not a prime number. So this will go without wasting time. 4 here alone. So this has even made this 2, 4, 35 has spoiled this option. So then B, 4 being here alone, 4 here alone has rendered this option wrong because 4 is not a prime number. 5. And this is where a bit confusion may come in. This and this here, because all numbers here are prime numbers. So, but the one that satisfies our answer is this and this. So the answer is what? D. This one, 3, is lacking here because 3 is a prime factor. What am I saying? Yes, because this is union of this and this. So 3 is a prime factor of 60, but they didn't put 3 here. So this has rendered this option wrong. So the answer is D. The answer to this question is D, a set of what? 2, 3, 5, 11, and the 2 respectively. And elements of this and this. Okay, thank you very much for your attention. Please, if you have any question, feel free to chat me up on WhatsApp. My WhatsApp line is on the screen. Please follow me, follow my page and like my page on Facebook. The page name is Fameternity the Schoolboy. It's on the screen. Please subscribe to my YouTube channel. My YouTube channel name is Fameternity the Schoolboy. It's also on the screen. Please, there's something I organize every month. First Saturday of the month is an academic competition, and I tagged it Academic Battle with Fameternity the Schoolboy. Every month is a free online competition, and it's free of charge. You register free of charge. Winners win lots of prizes. Please, I encourage you to register for it. It will help you to grow academically. Once you register, you'll be given topics to study for the month. Now, the one that is coming up on 7th of January 2023 is tagged is tagged Mathematics Battle 3.0 with Fameternity the Schoolboy. If you are interested, chat me up on WhatsApp so I can send you the link through which you can register. Please, we need sponsors for this. If you are interested in sponsoring this, please chat me up so I can send you account details where you can make transfer. Any amount of money you transfer will go a long way motivating and encouraging our students, our children to pursue academic excellence. Please like my videos, watch them, share with your friends, comment on them, share with your friends, share with your children, share with your colleagues, share with your students. Someone out there may need these lectures. God bless you. See you next time.